Right, I'm just going to give you an update. I'm making this new battery, right, and let's just see. Hang on a minute. Right, I brought it in here because I can't move the camera over there. It was in the other room, but now there's 192 lithium-ion cells in total, and they're wired in 3S series. That is 1, 2, 3 to give me 11.1 volts. And obviously I've learnt quite a bit about lithium-ion cells recently in the last few months, and about balanced charging and everything else. Now you'll probably notice that I've got these crossbars which are actually nickel connection strips. These connect all the cells in parallel with the cells below. Right, so there's actually 8 levels. I can't take them out because I'm actually in the process of sealing them inside a box. Now the box is actually, I'm using a fire blanket for safety. Now each bank of cells, now I'm just going to get this. This is just 6 cells, which I'm just going to show you this as a demonstration. I'm just going to put this on top so I can explain it. Right, because you have to allow these cells to vent in the case of to prevent explosion, because all these cells have got vents built in to actually vent. So what I'm doing is I'm putting these plastic straws, sealing at one end with wax, and then I'm sticking the straws along the cells next to the vents, so that when I eventually seal the cells in this box with the potting compound, these cells can vent safely through the plastic straws. If you know anything about density, you'll understand that the density of the matter of the straw is actually very weak. I mean, you can squish them with your fingers because they're very flexible. The idea is that once the cells are sealed inside this box, inside the fire blanket for safety, that if anything goes wrong, the cells can safely vent by compressing the straw, which is just basically to create a void in the potting compound. It's to create this void, a passage, if you like, tunnel, whatever you want to call it, so that all of the tunnels come out, is terminated at this end through these straws where they're all connected to all the cells. Right, now all these straws, I'm going to cut them up when I get to a certain point, and there's going to be a little steel box at one end, a little steel box around these vents, and inside the steel box there's going to be more fire blanket material, which is basically fiberglass matting. And what will happen then is that if anything goes wrong with the cells, for whatever reason, any flame or any gases or anything else will be contained inside a special venting section, where the gases can come out. So obviously this is my safe design of my lithium ion. Now when I've worked it out, there's also I've been learning about the safety boards which come with lithium ion cells. To explain it, when I took all the battery boxes apart, there was every single pack I took apart had well, they're all various, but they had these little safety boards. Now each one of these safety boards came with a specific pack of battery cells, but basically all lithium ion cells are the same. They all vary in voltage, 3.6 volts per cell or 3.7 volts per cell, and there's loads of these safety boards, and I've actually learned how to use them. So I am actually going to be using one of these safety boards. I've actually got here's another one. This one's for it's got thermal coupling, thermal monitoring on it. That's what these little orange things are, the thermal temperature probes. And obviously I'm going to be using the 3.6 volt safety board for the pack, because there's a few 3.6 cells and 3.7 cells. I'm going to go for the safer lower voltage circuit. And now some of these I've got battery monitors on. Took me a while to figure it out, but when you disconnect some of the safety boards, what happens is they lose their programming, but some of them don't, so I'm going to be using one which doesn't actually lose its main programming. I've actually got some on a test over there right now. I don't know if you can see. There's a voltage thing over there right now, but on my table the wire's not long enough to move the camera, so I can't really move it over there. But I'll just pause this a moment, just a minute. Right, okay, here's the battery box, which I've actually opened this one, and it's got a voltage bar graph on it. Now I've got several of these bar graphs now, and basically when I press this button it tells me how much power there is in the battery. It's difficult to do this with one hand. Hang on. See if I can do this. There we go. Right, you see this bar graph, it gives me 3 LEDs. Now I've got a load of these circuits out of other battery boxes, and I've actually picked a couple out which work quite well even after disconnecting or reconnecting them, so they've got memory still. And I'm going to be building one of those in to this battery box, and it's, instead of monitoring 6 cells, it's going to actually be monitoring 197. However, obviously I won't be drawing current directly through the circuit. Instead the circuit's going to drive a MOSFET, power MOSFET, and the power MOSFET will carry most of the current, and the circuit itself will simply be monitoring the power that's being driven through the power MOSFET and monitoring the voltage of the whole pack. And the one thing that the safety board will be doing, however, is it will be monitoring and relaying the charge current to the cell pack, the entire pack, so it will get an idea of if there's a fault condition there in the whole pack. And another thing about these cells, I mean these straws, these vents which I'm building in, is it makes it quite easy. This is a temperature thermal coupling which is on one of the safety boards. It actually makes it quite easy for me to insert the temperature probe down one of the vents and all the way down into the center of the pack, so that I can get temperature monitoring from deep inside the pack, which is one of my ideas. I'm going to be putting it, and there's enough room there for the vent to still work, so I'm going to be putting one of these temperature probes right down one of these vents into the center of the pack to monitor temperature. And I've virtually finished it now. I mean, I've just got a few more cells to put on top, and I've actually poured some potting compound in there, and I'm monitoring it very closely. As you can probably see, the potting compound is not going to block the vents, because the vents are terminated close to these straws, like I said, which are going to actually create a void, and the void is going to allow any gases to be terminated through these vents at one end. And then I've got to safely cap it off in such a way that the gases can, if there's such a problem happens, but I mean I don't expect that to happen actually, because the whole battery pack is such that there's a huge amount of thermal dissipation over this large area. I mean, the cells are going to be able to cool one another down and maintain a low ambient temperature of the entire pack. So, and the fiberglass fire blanket, obviously this is going to be wrapped over the top, and then once this is wrapped around the batteries on top, then I can put my control circuits and my battery management circuits on top of outside the fire blanket, so that actually the whole thing will be safely contained if anything did go wrong. So I'm thinking about safety number 1, reliability number 2, and I'm basically putting safety first, because these things, I've seen a few YouTube videos where these damn things have exploded. Last thing I need is 192 cells going off in my living room, so yeah, I'll be very careful. And I've also got myself one of these. Hang on, oops, where is it? Can't find the damn thing. Right, here we go. Got myself one of these. It's a thermal cutout. It's trip switch, basically. You know, like when if the current exceeds 30 amps, which is what I've rated these cells are going to be able to quite easily run once they're all sealed up. So this is 30 amp trip switch. So if there's a short circuit, the button will pop out. Let me just get this out of the packet. Actually, it's going to be difficult. Trying to do this with one hand. Right, there we go. So, get this right way up. It's a circuit breaker. There you go. And press to reset. So circuit breaker. So, and that's going to be in there. So that's the current cut out. And then there's going to be the actual board, which safety board I put in there, is going to monitor the temperature, and we'll also cut the power off if the temperature goes up to a certain point. So anyway, I'm just going to just tell you what I've rated this at. Each lithium ion cell is rated at 2,200 milliamp hour, but some of them are a little bit weaker and some of them are actually stronger than that. So I've stuck to a pretty low rating based on, and there's times, so there's times 8 3S, 3 in series, 11.1 volts. That equals 1,600 milliamp hours per bank of 24 cells. So there's 24 cells in this row here, and there's 8 more rows below that. You can't see them because they're in the box, but there's 8 more rows of these below that. And so 8 times 3S, 11.1 volt in series, and they are 8 rows, 24 cells tall. 8 times 17.6 amp hours equals 140.8 amp hours maximum. A current load of 30 amps maximum. 11.1 volt out of 16 times 3S, 3 series, equals 1.875 amps per 3S in series. So that would run an LED light at 120 milliamps for 1,173 hours, or 49 days constant. So anyway, that's really what this pack should be able to do. But obviously, as I know, these are not brand new cells. Some of them are fairly old, so some of them are a bit weaker and than that. So at some point I'm going to be, this trip switch is designed for surge current. Actually, it's designed to cut out in if the current exceeds. But I'm also going to be building a little when I put the MOSFET driver in there, I'm going to be putting a little electronic cutout as well, which basically if there's a short there and the power drops to a certain point, it will also cut the power off as well. So I just want to be extra safe because you might remember I built the original battery boxes out of biscuit tins, and they've been running happily for well over a year now, and they're currently being charged up by the sun right now. I've got one box which was configured at 14.8 volts, which is that one, and the other one is configured at 11.1 volts, but it's obviously taking a charge right now. And so when you're charging these lithium cells, the maximum voltage to charge the cells is about 4.2 volts per cell. And I actually plan on putting one of the safety boards in these boxes at some point in each one, so they've got them monitoring them. So I've got to reconfigure these boxes now and to put safety boards in them, which I've figured out how to use. So those have been running quite safely and happily, and because it's only solar power, they're not being charged constantly, only during the daytime when there's a certain amount of sun, and I've never actually experienced them. And this light is actually running off the solar battery right now as well. So when I turn the light off, you'll see the current drop on the top one. There you go. It's dropped to 20 milliamps now. So this light is actually running off my solar batteries as well. So they'll be running quite happily. So anyway, that's just a little update on the new battery project I'm doing right now. So I don't think there's anything else I missed out. But yeah, some of these have got the vents below the cells, and these top row actually need some more. I've got to put another vent down the side here, down the side of this one here, and I'm going to put another vent on the middle there. But the termination of the power couplings come out here. That's a positive. You can't really see there. That's the positive terminal. And I've cut those vents off short because I didn't want to melt them with my soldering iron. But I'm going to be, you can actually stick the straws on the inside to extend them, which is what I've been doing. I've actually widened them a little bit. And if I get another straw, for example, and I want to extend these, I just let me show you that. It's a bit awkward. Yeah, well, I'll just basically twist it and get it so that it goes in the inside of the other straw. Then I can extend them and until I get to the right height. But I actually widen them with my pliers a little bit. Well, narrow nose pliers, but it's a bit fiddly getting them in actually. But there we go. I've got that one. So there we go. So you can see how I'm extending them. There's that long one I've just stuck in there. And press it down, and then I can extend the vents. And obviously the straws aren't going to survive if there's a venting incident, if the batteries have a flamethrower or whatever. But that doesn't matter. The whole point really is that the straws create a mould, a tunnel inside the resin compound, the potting compound, so that it allows the gases to escape. So the plastic straws themselves are just to create the mould really. And once I've got this sorted out and all the batteries are fitted and soldered up, and this last row just needs soldering at this end actually. And another thing it's important to do is discharge the whole pack really down to 9 volts, so that each cell is at 3 volts. Discharge the whole pack so that each cell is at 3 volts before connecting more cells. That way there's no large amount of current flowing between charged up cells and flat cells, and that way it equalises the pack. And then I use the balance charger, the LiPro balance charger, to balance the whole pack out again. And once I've got that balanced, I charge it up with say 4000 milliamps to the whole pack, and then I discharge them down again to see that I've got them balanced. And if say this row in the middle was stronger and this row was weaker, then I would the next batch of cells I put on, what I do is I put the stronger cells on this side to compensate for the weaker cells, and the weaker cells on this side to balance it out. So eventually the whole pack balances itself out, which is what I've done actually. So now we've actually got I've staggered the weaker cells onto where the stronger cells were, and the stronger cells onto where the weaker cells were, so that the whole pack itself works together. And when I discharge them all, the last time I discharged this pack right down, it turned out that there was only about 0.04 of a volt difference between the cells, which is actually good. So the whole pack is really well balanced now, so which is important, because the last thing you want is a load of strong cells at one end and a load of weak cells at the other, because when you're discharging it you would actually damage the cells which are weaker, because they would have a lower voltage left in them than the stronger ones. So this is what I've been doing, balancing them out. Anyway, I've got this fiberglass fire blanket taped up with sellotape right now because it makes me itch. I can't stand the fiberglass particles sticking in my skin, so I've basically taped it up until so that it doesn't drag all over the place and drop fibres all over me, because I don't want fiberglass on me. It's really irritant. It's a skin irritant, you know, little glass fibres that stick on your skin, and it's not very pleasant. So I also use some sealing compound, which like a spray mist, to on the fire blanket, just like a sealant. It's just a shoe spray really, actually. It just makes the fibres stick to the blanket so they don't float all over and drive me batty. And I've got this copper battery here. This is proper battery terminal connection strip. It's, oh, I've just unravelled it now. But this is what I'm using to actually connect the groups of cells together. It's just very thin nickel tin, and so each bank is so I can balance them all when I charge them all, and the all the positive terminal from this bank of cells connected to the negative terminal of this bank of cells, so it's safe to run them on the negative side of these cells because these are connected to the positive. So, and I also got some there we go. I also got some heat-proof tape. It's called Captain tape. It's for doing transformers. It's fireproof tape, so you'll notice that I actually use some Captain tape on some of the cells on here because it's fireproof, heat-proof. It improves safety. It also prevents the potting compound from blocking up the vents of the cells. So if anything goes wrong and the cells do vent, they've got easy passage into one of these plastic straws, which will allow any gases to escape. So anyway, I think I've waffled on enough. So it's important that you think about allowing batteries to vent safely in the event, so you don't have a massive explosion in your living room. Very important. That's the most important thing, is if you're going to seal batteries up in potting compound, and make sure you give passage for the gases. Another reason why I put some wax down between them there is I would rather have hot wax spitting out behind a fire blanket, and it's just a little bit there actually. It's just to make sure that those vents don't get clogged up with potting compound, which is extremely low density. So obviously any gas is going to take the easiest passage out, which is going to be through the straws rather than somewhere else. Anyway, but I don't expect this to happen anyway, since the amount of protection I've put in this, or putting in this, is going to be far exceeding safety levels. I mean, just pay attention to one fact. When you buy a laptop from the computer, from the manufacturers, they put the lithium ion cells in plastic boxes, and these are flammable, which is, yeah, exactly, not safe. So my box is actually safer. It's actually a lot safer than a laptop that you would buy from the shop, because the original plastic boxes that they come in are very flammable. I mean, I've actually already proven that, because I cut some of the old laptop batteries of boxes apart, and I found out that the plastic was flammable. So I mean, yeah, the original manufacturer has obviously not considered containing the batteries inside fire blanket material, except for what? I opened something like I must have opened something like 60 packs, right? 60 packs of batteries, and this is the only pack I found that has a fire blanket on it, basically. And it's not even all the way around, it only goes partly the way around, right? This particular 6-pack here has a fire blanket on it. All of the rest of the ones didn't. So what does that tell you? Manufacturers don't really put your safety first, which goes to prove it, doesn't it?